Mr. President, we have a national emergency.
A nuclear weapon atop a ballistic missile has been launched from a freighter off the coast of the United States. The weapon is not designed to kill Americans, at least not directly and right away. Instead, it is meant to unleash EMP, an electromagnetic pulse that destroys electronic devices and power grids. As it detonates 300 miles above the United States, the single explosion unleashes electronic waves 1,000,000 times more powerful than any radio signal on Earth. In the United States, nearly all computers fail. Telecommunications end. Transportation comes to a halt. The stock market's crippled. Bank accounts disappear. Federal officials warn EMP could paralyze America, instantly returning our country to a pre-industrial age. And they say we are utterly unprepared for it. EMP. It's a terrorist dream. An American nightmare.
Okay, we're at phase 1 right here. We're attempting to disable the safety features for the microwave. We do have a make. It is a Space Maker, produced by General Electric. Disabling safety feature. Gaussian probability distribution is one of the most amazing things. It goes around the central convolution theorem. We have found that testing with different microwaves, that the Gaussian distribution works very well. If you look at the peak at the lower bottom of the slide that you see right now, you'll see that's a broad distribution. I would say that would represent older microwaves from the 1980s and the early 1990s. Newer microwaves, they focused on the water molecule. So if we can go to the next slide, we find that this is like the overall distribution. Just imagine this distribution narrowed for newer microwaves, and for older microwaves, it's more broadened. Which is a good thing as far as EMP approximation. So we have taken this account, and we're going to move on. Okay, tell me a fire in the hole. I don't like that blinking. I can try. Okay. Making sure that this is operational and functional microwave. So we have a cup of water in there, and we're going to see if it's warm. Okay. Does it feel warm?
Yeah.
Okay, it's functional. Okay, we have James Pittman here. He's in the reserves. He's going to go ahead. He's only a high school graduate. However, he wants to become a chemical engineer in the future. So we want to show that just an average enlisted man can actually do this recipe. So right now he's taking safety procedures. Make sure you get the goggles. Okay, go ahead. Okay, so yeah, go ahead. Okay, in this experiment, what we're about to do is we're going to do the 1 hour cure method. We're going to see how fast this can make a conductive bond between aluminum, copper, and steel. Okay, so Mr. Pittman right now, what he's doing, he's going to roll out a piece of aluminum foil, and he's going to prick it with a small knife. No, he's slicing off a piece of aluminum foil. Now what he's going to do is going to do varying poke holes. Okay, this is a Casio calculator. Okay, we're going to leave it on the on position. Okay, so you can see the number right there. We're going to leave it on. Hopefully the battery's going to be charged, but this is our first approximation right here. Later on we're going to try that track phone, which you see right there on your left side. That one right there. Okay, do you have the pricked holes? Let's see what you have. Okay, I believe it's a proper time to go ahead and use a space blanket material. Okay, we're going ahead and we are going to apply the silver epoxy. We had a makeshift brush using the brittle pads. Make sure you get both sides. We are wrapping it so it's fully enclosed. Make sure when you use this material that it is in a well-ventilated room. As you can see, we have the kitchen sink fan on and also the door wide open. Okay, now he's going to make the solid aluminum foil outer shell. So this is a triple layer application. James, one. Okay, nice and packed. Now what Mr. Pittman is going to do is he's going to apply the silver epoxy on the surface, and he's going to take what you see over here. This is a household copper cable which is in every single household all across the country. You can grab this out of the walls if you have to. So he's going to take the stripped end, he's going to do a longitudinal and also a latitudinal cross-section around that and apply the silver epoxy. Okay, suggestion, go ahead and rub the Brillo pad onto the copper wire. Take this edge right here, rub it. Get it nice and smooth. Okay, lateral transition. Okay, that should be enough. Now let's try to douse it in the silver epoxy. Probably a suggestion in the future, we should probably douse the copper wire beforehand. So we'll have to make a change to the recipe, but we'll see how this works. Yeah, keep it on the countertop, make it wash out through the pans.
Everyone.
Okay, so essentially what we're going to do here, we're going to let this cure for about 1 hour, which is the minimum time for curing. The instructions say it actually should be 1 to 2 hours followed by a week. But however, we want to try to test the time on this material, so we're going to go ahead within 1 hour and we'll commence our experiment. Okay, Sergeant Pittman is about to apply the silver epoxy to the grounding. He's inserting the cell phone, I'm sorry, the calculator. That's in the protective coating. Okay, we're going to make a minor adjustment here. Hold on a second. Okay, we're going to use a standard Brillo pad. You can buy at Publix. Okay, notice that we're scraping the steel. We're trying to clean it to make a good conductive bond. Okay, so we're taking the standard toothbrush. Okay, we are going to...
That's what it's supposed to look like.
Okay, we're going to go ahead and apply it. Okay, right around the ground of the sink. Notice that we're going below the rubber part, so we can actually get a good ground. We're going to do 3 wraps here. We apply the epoxy to the copper wire. Okay, and we're going to try to do as tight as possible. Okay, so how many bonds do we have there? Do we have 3? Okay, we're applying more silver epoxy with the brush. Okay, we're going to do a 10-second blast on this microwave that comes from the mid-90s. We have it covered for EMP protection, so we're going to go ahead. James, tell us when fire in the hole is. Fire in the hole. Back up.
I'll be surprised if this is.
Holy shit. Still works. They do an addition.
86 times 3.
Okay, this is with no shielding whatsoever. I'm going to back up a little bit more.
Yeah.
Okay, let's take a look at it, see if it works.
I'm not grabbing that with my bare hand.
Okay, that's a 10-second blast. Looks like the LCD screen is completely blasted. The thing is completely dead. Do you concur, Mr. Pittman? Absolutely dead. 10-second blocks without shielding.